Hello students, in this video we'll prove a Lower Michigan math competition problem that involves a point of tangency on a certain polynomial. Let's be given the polynomial p of x. And as is standard, we use the year, x to the 2025, plus x to the 20, plus x to the 15, plus 2025, right? So there's some high degree polynomial. And then we want to prove that for any point AB in the plane, there is a tangent line to P. There is a tangent line to P that intersects the point AB. That intersects the point AB, okay? So this is an example of an existence result, right? And so we want to think in our database, I want to think about known existence results, right? So one thing that comes to mind when I see a problem like this is intersection of a function and a line is very reminiscent of the intermediate value theorem. So just a thought process, initial thought on a competition problem like this, initial thought would be the intermediate value theorem. Or some variant of it, okay? And so here's the idea. So let's find the equation of the tangent line. So let's do the derivative. So what's p prime of x? P prime of x is going to be 2025 x to the 2024, goes down by 1. Then plus 20 x to the 19. Plus 15 x to the 14, and then the 2025 goes away, right? So at a particular point C, so at any point C, we have, I'll write down the equation of the tangent line. The equation of the tangent line, L of x, is going to be what? Well, here's the slope, right? So the slope is going to be 2025 C, right? C to the 2024. And then plus 20 C to the 19 plus 15 C to the 14 times x minus a, x minus c rather, and times the function value at the point C, right? And so the function value at the point C is what? The function value at the point C is C to the 2025 plus C to the 20 plus C to the 15 plus 2025, okay? It's a mess, right? The equation of the tangent line is a mess, right? And I have to show somehow that this what? Our goal now is to show, so goal, show that L of A, because in other words, that intersects A, right? That L of A is equal to B, right? Or L of C rather, right? So if I plug in C, I'll give you the point A, right? So in other words, I want to show that this line over here, so how do we show that this line over here intersects that point AB, right? Okay, so the point AB, so when I plug in A to this thing over here, what's going to happen? When I plug in L of A, what is L of A? L of A is going to be this whole thing, just going to be 2025, C to the 2024, plus 20 C to the 19, and then plus 15 C to the 14th, and then A minus C, plus this term over here, right? Plus these terms over here, plus C to the 2025, plus C to the 20, plus C to the 15, plus 2025. And I want to show that this is equal to what? That this is equal to B, okay? So what do we really have over here? So I'm just going to rewrite this, and all I'm going to do is I'm going to just focus on the fact that I have a what here? I have a negative C over here and a C to the 2024, right? So this over, and then I have a plus C to the 2025. So that's a C to the 2025, right? And then that's minus, so I'm going to have negative 224 C to the 2025, C to the 2025, plus the lower order terms, right? Then every other term is a lower order in C. Lower order in C. I'd like this to be equal to what? I'd like this to be equal to B. So now what do we have over here? So now let's take this whole expression over here and call it Q of C. So our goal now is to show that Q of C, we need that Q of C is equal to B. But Q is an odd polynomial. And that implies that the range of Q is equal to R, right? If the range of Q is equal to R, I can certainly find a value of C for which Q of C is equal to B, because this goes, it's an odd degree polynomial, right? It either goes from positive infinity to negative infinity or negative infinity to positive infinity. It's a continuous function. There's my intuition with the intermediate value theorem, right? Because basically I'm just using that in some sense, right? I'm using the intermediate value theorem in continuity to show that all those values, right, for an odd degree polynomial over here. And so I'm really exploiting the fact that the degree, together with the intermediate value theorem and continuity, allow me to conclude that there's a point of intersection with a tangent line to any given point in the space. Thank you very much.